So it is time to start class, and hopefully you guys are finding and opening up your review sheet. Let me just remind you that you need to complete all assignments independently without assistance, and that in here, the chat box should be limited to the content of the lesson. You guys are great at being respectful and courteous, so keep up the good work. And here's how to find that IA review sheet if you want to download it from here. So those three little lines on the whiteboard, pick My Attachments if you want to download something. And then if you want to look at the presentation on your whiteboard, I haven't released it yet, but at the end of class, you can go to My Presentations and then go through it on the whiteboard. But I wanted to go through it as a group during class today, and then I'll release it, and you guys can page through any questions that you missed. All right, so green check or red X, let me know if you are ready. So let me turn off my mic while I'm chatting to someone privately here. Hey, Honesty, and hello, Demetria. We are looking for your review sheet, and if you can't, if you don't have it yet, you can use these three little lines to click it and get it as my attachment. You can download the review sheet right from here, and then give me a green check once you're ready to go, and a red X if you're struggling. And hello, Ben. We are going over our review sheet, and we're just getting started, so you came in at a good time. A green check when you're ready, and a red X if you are struggling with that. And I'm just going to talk for a sec about academic integrity. So we've got to treat our assessments as single browser. And that means that you only have the assessment open, that you don't have anything else open. There was a couple people on the quiz where they, the last quiz we took, where they knew more about Cobalt than I did on the short answer question. And that tells me that either you're an avid lover of Cobalt or that you are not using a single browser. So yes, we cannot open any other browsers. However, you should use your periodic table. Oh, this one's not the blank one though. Here's a blank one. So you should use your periodic table on the interim. And fortunately, if you haven't printed it out, I have a copy in here. And you can just maximize the image window during the test, and that will give you your periodic table. And sorry, something got distracting to me. Hang on just a sec. Still trying to figure out Jigsaw. Okay, so hello, Ben. And yes, single browser, you can use your periodic table, and also you should have a calculator You cannot use a calculator on your phone. You could use a calculator on your computer though, but no phones if you don't mind. So you've got to take the assessment by yourself. Don't get help from anybody else. And please don't redistribute, copy, or share any part of the test at all. Questions about academic integrity? Maybe a few more green checks for that you're ready to go, or a red X if you're not. Okay, I'm just gonna take a sec here and check some private messages. Okay, and I'm still waiting for some more green checks. So Demetria, are you ready to go? Amani, do you have your review sheet out? And hello, Jeffrey, how's it going? Let me know, green check, if you are ready to go. Makai, is your review sheet good to go? Gibson, how about you? Nicholas, hey, Porter. Hello, Scotty. Terence, can I get a green check if you're ready to go? Tamara, this IA is over everything that we have covered and nothing that we haven't covered. It's only stuff that we've covered, and it's all on here. Ooh, if you can't hear, gear and refresh. Okay, cool. All right, good. Nick, can you hear me now? I like that commercial. Excellent. And let me make my whiteboard big. So many buttons. Refresh your assets. Nope, I didn't want to do that. I wanted to refresh the layout. That way, when I open my whiteboard. Okay, so you can get rid of me if that's a problem, if I'm in your way for this. And then you guys can match these on the board. If you don't have tools and you want tools, please tell me in the chat. And hello, Amir. We are just starting our review for the interim. So make sure you find your review sheet. And I will put the slides on Rome at the end of class if you need to go back and get anything. So y'all can write on the whiteboard and match these up. Or if you have no idea what's going on, you can change to a red X, and that'll tell me that we need some more assistance. And let's see, you all told me the other day what you guys wanted to cover, and that was periodic table and half-life. You wanted me to focus on a little bit more. Thanks, Honesty. Nice smiley face. All right, so do you all have board tools? Hey, there we go. Someone had board tools. Let me move that back. So you can pick the little A with the square around it to write, or you could pick the line if you want to draw lines. But as long as you are on that little arrow at the top, then you're going to be picking up things and moving them around. There's a paintbrush too if you want to do paint. All right, so B is +3. cool. A is -1 and C is +1. Okay, so y'all in the chat, tell me if you agree or disagree with what's done on the board. Excellent. So we've got 2 agreeing. What about the other 18 of you guys? Hello, Isaiah. How are you today? Oh, good. Oh, good. So we've got 3 in agreement. I would love to have some additional participation here. It's super important to participate. And yes, they were correct. B, A, and C for those. If you don't understand something, give me a red X, and then I can explain additionally, or pick up the mic, or type in the chat. Oh, no worries, Akia. All right. I am moving on. To get the charge, you take your number of protons minus your number of electrons, and that gives you your charge. All right, I don't see any red X's, so I am moving on to number 2. And there will be additional time at the end if you have any questions you'd like to ask one-on-one, or if you need to go back through the slides. All right, let's do this one in the chat. Atoms with a positive net charge, do they gain or lose electrons? All right, so we got 2 lose. Yeah, so that one is lose. When you have a positive net charge, to get a positive net charge, I don't know where my P's and E's are, you have to lose those electrons so that you have more positive charge. And then atoms with a negative charge, what do they do to electrons? Do they gain or lose? Right, they are going to gain electrons. And remember, you cannot gain and lose protons unless you're radioactive. That's the only way. So lose and gain. Okay, number 3, we have to put this one down on the whiteboard. Oh, good, it's working, because that wasn't working earlier as well. All right. And hello, Hadia. Anyone else come in? Y'all can put this on the board or give me a red X if you don't know how to do it. But I need some participation. Y'all, the best way to learn is to participate. Yes, so participate one way or another. Excellent, excellent, good. Show me those red X's. If I don't know that you don't get this, then I can't help you to understand it. So you gotta tell me you don't get it. Okay, so let me check the ones that are good, and then we'll go through them here. So we're good. We're having trouble with our neutron number. Yes, Nick, you definitely need a periodic table. And I have my regular periodic tables, but I don't seem to have my backwards one, you know, that you guys can see. I may need to reprint that. Wait, I found it. It was just underneath something else. Okay, so you need your periodic table. And I'm also going to tell you that this number over here, the -6, that is telling you the mass of this particular isotope of lithium. So lithium, oh, let me put my camera back up so I can tell if I'm on the right spot. Okay, so lithium, on the periodic table, it says the mass is 7, but this is the average mass of all the isotopes that exist. And on my little table here, this one is about lithium-6. It only has 6 particles in the nucleus, 6 AMUs for the mass. So it's number 3 on the periodic table, and that tells us how many protons it has. It says 3 protons, and so if it has 6 total particles, 3 of them are protons. That leaves 3 of them to be the neutrons. Good, good, there we go, awesome. And since it's neutral, then we have the same number of protons and electrons. I'm sorry, the erase feature doesn't work, but I used it and then I erased everything by accident. It was horrible, so I'm going to keep that turned off. But we can see. I'll circle that 8. Okay, and the 2, so you guys can tell them apart. The correcto answers. So let's take a look at oxygen. And oxygen, find there we go. Oxygen is number 16 on the periodic table. Or it's number 8 on the periodic table, has a mass of 16. Since its atomic number there is 8, that means it has 8 protons and 8 electrons, because all of these isotopes are neutral, so the electrons and proton number will be the same. And then we've got 16 mass particles minus the 8 protons, leaves us with 8 neutrons. And then the same thing occurs with helium. And let me put up the picture with all of them filled in. So, and they're not always like 3, 3, 3 across, 8, 8, 8. That's not normal necessarily. That just happened to be a fluke. The way I made up these numbers, I just randomly picked an isotope that I knew existed. And it turned out that they were all equal. So if this makes more sense now, give me a green check. Get rid of your red X. If you still have questions, pick up the mic or put them in the chat. And anybody else that has come in and hasn't given me a green check that they're ready to go and they're working through the review sheet, please feel free to put that green check up so I know you're here and you're working with me. Thank you. Thank you. All right, so we're good to move on. Again, at the end of class, we have time, and I can help you all individually while everybody else is practicing. All right, let's fill these in. And there is a typing feature too, if typing would be faster. It's a little A with the square around it. But this works. So N for neutrons. Oops, see, there I go, moving that around by accident. Okay, so N is the neutrons. Purple is the electron, and red is the proton. Tell me in the chat which two could get switched and it'd still be right. Yeah, if you switch the neutron and the proton, that's perfectly fine. FET likes to put red or proton but you could just as well have read for neutrons. It doesn't matter. Yeah. Now, if there's a plus sign in the middle of one of the circles, then you have to have it be a proton. Okay. All right, so identifying the element names. Okay, I'm going to get rid of me. And remember, the element name is based on their number of protons. And if you guys want to put these in the chat, you can do that too. You don't have to write on the board. I'm not getting any red X's, so I'm assuming you guys know how to do this. All right, anyone still with me here? So what's this first element over here? Yay! And how do we know that this is helium? Oh, yeah, it's 222 is the number of particles. You can see that there are 2 protons. That is what does it, is the number of protons. Thank you, Honesty. How about our second element over here? What is this element? All right, do you all agree with Honesty? Is this beryllium, or do you want it to be, or do you think it's a different element? Nick is agreeing. All right, we are all in agreement that that is beryllium. Excellent work, guys. And I just put the full isotope name up here by adding the mass on the end of it. All right, so we got helium and beryllium. Number 6. All right, so use the colored periodic table. Match which group belongs to the color. Ooh, good, good, good. Thank you. I got some red X's. Excellent, excellent. So this one, oh good, I see someone on the board. And the noble gases, purple here, purple is not gonna be for the noble gases. Where can we move purple to? What is the name of this purple group? There we go. These are the halogens. They have 7 valence electrons and they're highly reactive. They are the most reactive nonmetals. So noble gases, ZY for yellow. The yellow group is not the noble gases. The yellow group is the boron group, they're named for the top element in the group. And so actually yellow is not going to be used because we haven't gone over the boron group. All right, we've got alkali metals being A. Those are red. Correct. Those are the most reactive metals because they are right here on the end. They are like one step away from being over here with the teal group. Hey, I see that noble gases are labeled as teal. Awesome, thank you. And then B, orange, those are the alkaline earth metals. Oh, I see, that's an I, not a Y, right? It's all right, Nick. My handwriting isn't very good either on the board. I mean, my handwriting's never any good, but on the board, I'm sorry, it's even worse. So this spells chaib, C-H-A-I-B. Oh, the transition metals are the white ones. They transition between the first half of the main group and the second half of the main group element. So those are all the white ones are transition metals. And let me go back to my actual key so that you can see it and read that easily. Because my typing is nice and neat. All right, so y'all with the red X's, do you still have questions about this? Okay, this one's really just a memorizing thing. There aren't too many things to memorize, but you can remember that alkali metals are group 1, they have one name. The alkaline earth metals is group 2 and it has 2 names. All right, and which of the following are false? You can just put these in the chat. All right, so D is false. What else? What do the rest of you guys think? Oh, and we named this guy Zorblax. So listen to Zorblax. You may have a good thought there. Thank you, Tyrese. Thank you, Honesty. So now I've got D and or C. I think Honesty, you put both of them, right? Yeah. Oh, Tyler's going with C. Lexi, you're throwing B into the mix? Oh no. I'm so sorry that you can't see the slides. It's probably your internet connection being a little bit slow. Can anyone else not see the slides? All right, so Lexi's changing her B to C, and you guys are correct. It is C is false and D is false because nonmetals do have very low melting and boiling points. Oh, Demetria, you can also look at your review sheet because we're just going right in order. So we're on question 7 on your review sheet that C and D are both false. And it's very true. Nonmetals have a low melting point and boiling point. That's why they're gases for the most part at room temperature. And I'll try to be sure and mention that we're on question 8 now. So I think we can answer question 8 in the chat. And that way, if you don't have slides, you can still check your work. All right, so we got B from Honesty. What about the other 22 of you guys? What do you think? Amir, what do you think? Kaylee? Michaela? Makai, what do you think? And hello, Tyrese. I don't think I said hello to you. I'm sorry. Yep, silver is a metal, definitely. And so that one is the correct description there of a metal. So 8 was B. Number 9, I'm going to put this one on the whiteboard, because that way y'all can circle them. So this is number 9. Metalloids are similar to metals because they are blank and blank at room temp. And metalloids are like non-metals because they're blank. All right, can I get some more circles and participation out of the group here? You all agree or disagree with opaque and solid? Cool, and you can circle them. If they're already circled up there, feel free to put another circle or circle the other word if you agree with the other word. And non-metals, they're like them because they are brittle. It looks like we are all in agreement here. Nice job, because those are the correct answers. A, metalloids are similar to metals because they're opaque and solid. And for B, they are like nonmetals because they are brittle. Ooh, we can do this one in the chat. Elements that share the most characteristics are those within the same, what? Group or period? All right, so we've got 1 for period, 1 for group, another for group, anyone else going to chime in? That's good. Thank you, Lexi. Period. Oh, now we're at 50-50. I need some more input here. And think about like the noble gases, right? They're all inert. They're all inert. They don't react. They're all gases. What are those called? Those are groups that go up and down. So groups is the correct answer there. All of the alkaline metals are extremely reactive. The alkaline earth metals are a little less reactive. They all have 2 valence electrons, and they form +2 ions. So these are groups. Groups are also called families. And like your family has a lot of similar traits and characteristics, so do families of elements. So the vertical thing, and think like your family tree, it goes vertically, right? All right, number 11, using your periodic table. Yes, periods are horizontal. Like a sentence, you write horizontally and it ends in a period. Yes, I'm full of helpful ways to remember things that have nothing to do with science. I mean, the information does, but the way to remember it may not. All right, so which element is most similar to aluminum there? So we've got silicon, hydrogen is way up over here. I cut that one off. Does that tell you that's the wrong answer? We have indium, and germanium. And yes, indium is the correct answer. And why is indium the correct answer? Yes, it's in the same group or family. Thank you, Amani. Thank you, Lexi. Oh, I think someone else was going to say that too. It's okay for you to keep typing and put in the answer after I've said it, because the more you can put those answers down with your fingers on paper, the more ways you get that into your brain, the better you're going to learn it. So yeah, feel free to put in the chat the answers, even if it's after you know the right one. That'll just help make those connections up in your brain. Ooh, okay, which metallic group is considered the most reactive? And Nick is going with alkali metals. Lexi, is that an A or are you unsure? Or you're agreeing? D, C. Remember, to be more reactive, you want to have fewer or more valence electrons. You want to be really close to that octet, which is your 8 valence electrons. So if you're a metal, you're just going to have 1 valence electron. And that is D. The alkali metals are the most reactive. It's because they have 1 valence electron and they just have to, boop, they lose that 1. And then they have a configuration, their electrons look like the noble gases, which is a stable electron configuration. Yeah, for non-metallic, which one's the most reactive? Which non-metallic group is most reactive? Most reactive. We've got a D and, well, no, the D was from before. C, and we've got an A. And another C. You guys are correct. It is the halogens, the purple ones that are most reactive because they have 7 valence electrons. I'm in trouble counting on my fingers here, right? I was going with 8 is noble gas configuration, very stable. So they have 7. All they need to do is gain 1 really quickly and they will be stable. And which group is most stable? Yes, A, the noble gases. So this is number 12. The answer is DCA for number 12. Alkali metals, halogens, and the noble gases. Number 13. Match the following image with the correct state of matter. All right, so it's looking like we've got BCA. And I will also point out that if you can see the little particles of the solid, they are in place on their crystalline cube, which you can see those lines in blue a little bit. They're very light, but those pieces are just sitting there vibrating. And so, yes, BCA is correct. Liquid for the top one, gas for the middle one, and solid for the bottom one. And that was number 13, BCA. Okay, number 14 is our half-life question. And let me put this on the board. And remember, if you are struggling with this, definitely give me a red X. And let me just take a sec to re-explain half-life, because this is one of those things you all wanted me to cover more in depth. Half-life is the time it takes for half a sample to degrade. So, getting a piece of paper. So if this is our sample, right, we have 10 grams of actinium-227. The half-life is 22 years. So after 22 years, we are left with 5 grams of the actinium-227. The other half didn't like poof, go up into space or something. It didn't just disappear. It actually turned into a different element. It either lost a proton or gained a proton, but it's not actinium anymore. Now it's a different element. It's still there. So after 22 years, we have 5 grams left of actinium. And look at that beautiful table filled out there. Give a round of applause to whomever filled out that table. Thank you. It's wonderful looking. Okay, so after 22 years, we now have half of our actinium left. So after another 22 years, half of it is going to decay again. So now I have a quarter left, or 2.5 grams left. All right, and then after another half-life, so if we kept going after 66 years, we'd have half of it left again. And so what's half of 2.5 grams? What's half of 2.5 grams? So close. Take 2.5 and divide it by 2. And that's the way to half things. You just keep dividing by 2. Yeah, 1.25. Now I've got 1.25 grams left. So at the beginning, you have your whole sample, right? And then after one half-life, you have half your sample. And then after 2 half-lives, you have a quarter of your sample. And then after 3 half-lives, you have 1/8 of your sample. And then if I could do this again, get it in half. Now I have a 1/16 of my sample left, and then a 32nd, and a 64th, and you can just keep cutting it until it's smaller and smaller. So you can use the table where we put down 0, 1, 2 half-lives, and then we increase our time. Every time you go down, you add the half-life. So if we did the next one, it would be 66. And then every time you go down the mass, it gets cut in half. So half of 10 is 5, half of 5 is 2.5, half of 2.5 is 1.25. And I heard some green checks come in there. Thank you. And then we can look at the question. It wants to know, how long would it take to decay until there were 2.5 grams left? So how long is time for 2.5 grams? So I can just find the correct number in my table, which is the 44. Anyone else going to change to a green check or ask a question? Okay. Wow, look at that. Good job, guys. And there is the table typed out for you. And again, I'll put this on the whiteboard so you can page through it at the end of class. Okay, true and the false. This is number 15. True and false. So circle true and false on the board. And then the false ones you can make true either in the chat or on the board. And if you disagree with something, you can either circle the other true or false, or you can do that in the chat or pick up the mic. All right, so now we just need to fix our false questions, and I will tell you if these all look good. A is true, B is true, C and D are false. So guys, how can we fix C and D to make those into true statements? All right, so solid particles do vibrate. Very nice. And tearing paper into little pieces is not a change of state. What is it? Thanks, Brittany. It is a physical change. And yes, if the, well, you know, Amani, we can have a change of state is a physical change. But yeah, if the paper stopped being a solid, then yes, it would be a true statement. That's correct. Yes. So good job, guys. You fixed them the same way that I would have fixed them. So A and B are true, C and D are false. That's for number 15. And now we're going to continue with number 15 with the rest of them, E, F, G, and H. So go ahead and circle if those are true or false. And what about H? If you cool down a propane tank, there will be less pressure in it. Propane tank would be like the tank that goes on a grill. Those are propane tanks. Or if you have one of those little propane tank and to make like a little flame for soldering and plumbing and stuff? Okay, so there is one that isn't right. Y'all want to put in the chat which one you think is wrong? Or you can circle the other word out on the board. Okay, H. How about everybody else? What do you all think? F. Anyone else want to chime in? I'd love to have some more participation. Thank you, Brittany. All right, so I will let you know that these are all true. So, but let me talk about a couple of these that you're unsure of. I'm going to move these circles all over to true. So if you put a balloon in a freezer, the temperature goes down, right? And when the temperature goes down, the particles are going to move around less. And since the particles move around less, the balloon is going to shrink. And the volume will go down. You can actually try that if you have enough room in your freezer and you have a little balloon. You can just use any balloon, but just blow it up small. Measure the distance across the diameter, put it in the freezer, take it out after 10 minutes, and you'll see that the volume has decreased. And then on G was true. Tamara, yes, we're going to turn in the study guide and get a grade for completing your study guide. You bet. G, if you took the balloon into a vacuum chamber where there's less pressure, the volume would increase. So if you remove the pressure on the outside of the balloon, then there's more pressure inside and it will increase the volume to neutralize that pressure. And H goes right along with F. Both of those, the temperature went down. And when the temperature goes down, the gas particles move around less, and then there's less pressure in there. Oh, well, thank you, Tamara, for completing your review sheet. Completing your review sheet will also help you to do better on the interim. And so that's another reason I make you turn this review in, because just by doing this, you will improve your interim score. So 15, E, F, G, H were all true. 16 is a multiple choice question about liquids. All right, thanks, Honesty. What do the rest of you guys think? Oh, good question. I just got this in a private chat as to where the review sheet is. And you can look for the review sheet. It's on the whiteboard. You can click on the 3 lines and go to my attachments and get it there. And then it's all over the canvas. It's all over Canvas. Sorry, I was like reading about the cats are liquid. It's in your announcements. It's on your calendar. It's due. I put 4 o'clock today, but anytime today would be great. Tomorrow would be great. Yes. So yes, C is the correct answer there for the liquids. Okay, cool. Milk. Ooh, that's a great question, Amani. No one has brought that up. So I don't know. So 17, I was looking around. I found some great gifts to go with this, just to have a little brain break before we finish this off. So on the left here, is a picture of super cooled water. And so if you are really careful about cooling water down, you can get it below its freezing point and still have it be liquid. And then when you pour it pours out as a solid. And then on the second one, this is a way to condense water. I saw a program about this on TV that they use materials that are found near the villages, and this one was in Ethiopia. And yes, Lexi, that is very true. I don't think that'll work, Amani. But anyway, this drinking tower, and everything is made from materials that are easily attainable and inexpensive. And this can allow people to not have to walk for clean water. There was one lady that was walking to clean water 4 or 5 times a day to get water for her kids. And she was spending upwards of 8 to 10 hours going to get water and back and forth from her village to the clean water supply. And so this can take all that time away and give that to them to do other things. So hopefully this will work and they'll be able to build them all over the place where you need fresh water. So yeah, I just wanted to share those things with you. Some real life examples of what we're doing in class. So 17A, during condensation and freezing, does the material absorb or release energy? What do you think? During condensation and freezing, does the material absorb or release energy? We're on 17A. Okay, so I'm getting some red X's. So let me explain this. So when you're condensing or you're freezing, the particles are getting closer together. When you condense, you go from a gas to a liquid, and so those particles are getting closer together. In order for them to be able to move closer together or to lock in place with each other, they're going to have to lose energy. And in order to lose energy, it has to be released. So it has to be removed from the system. So the system has to release that energy. And to do this, the energy being released is only going to change how the particles are oriented. So the temperature is actually going to stay the same. So you're going to release the energy and the temperature is going to stay the same. That you may have an old review sheet that stays the same, was not a choice on. If you do, go ahead and add it in there and pick that one. Oh, and here's that propane torch. The propane torch here is being used to melt the jawbreaker. So, yep, that goes with melting. All right, so what do you guys think about B? Now, knowing the answer to A, during melting and boiling, this is the uphill part of our heating curve, is the material going to absorb or release energy? Right, they're going to absorb that energy, and that's to pull the solid particles apart, turn them into a liquid, or take those liquid particles and move them further apart as a gas. So all the energy is going to change the spacing of the particles. So what do you know about the temperature? It's not going to go up because all the energy is going to change the particle spacing. So it is going to stay constant. Oh, I didn't change that one. The down should stay the same there. I almost got it fixed. So don't look at that down part. So what is this change of state called? But it's going from a solid straight away to a gas. Evaporation is when you go from a liquid to a gas. Condensation is gas to liquid. This is solid to gas. Started with an S. Oh, you must have missed the day we talked about this in class. I have a whole YouTube channel, and all the recordings are in Canvas in that recordings module. So if you ever miss a class, you might want to check that out. And it starts with sub. So you must be hungry. I'm hungry too. Oh, it's called sublimation. Sublimation. I think we did this last week, Wednesday, Thursday, when we did the heating curves. All right, so here's our heating curve, and the sublimation only had the solid part and the gas part. Yeah, that was solid to gas, sublimation. Okay, there you go. Also, if you practice the Quizlet, that will help you with that. And we'll get to that in just a sec. Let's just finish up our last question here. I put it on the whiteboard so you can fill this in. This is a heating curve for water. Phase changes. Phase changes are just state changes. So boiling, melting, freezing, vaporization, condensation, sublimation, those are all phase changes. We've got the same interval for melting and liquid water. Okay, so let me go over this again. So when the temperature is the coldest down here, this is when you're going to be a solid. All right, so, and you're adding in heat as we go across. So as we add in heat, the temperature of that solid is going up, and then bam, we hit 0 degrees Celsius. And so now our ice starts to melt. So it's melting, and notice the temperature is staying the same, right? The temperature is not increasing, it's not decreasing. And so all along here from B to C, it's going to be solid, less and less solid, more and more liquid. And then when it hits C, that's when everything is melted, and now it's a liquid. So now we can start to heat that liquid. So our temperature is going up and up and up. Oh, you can move the webcam, or you can like X out of it. I have mine hidden, so I have no idea what I look like. There it is. But you can grab the blue part of the webcam and you can put it over the note box. That's what I usually do if I want to still see it. Okay, So what about the temperature? Oh, wait a sec. Was the temperature increasing during BC? Yeah, the temperature was constant. That's what you meant to pick, right? I'm going to move the CD down too. All right, so ice melting. Ice melting, that is from B to C. Oh, that's the one I chose to talk about. And liquid water is from C to D. Yes, these are all correct. Yep, this is all correct. I've got it up on here too, on my presentation. And then let's finish up our last little section here. On the whiteboard. Move my webcam. I wish I could resize it to make it just a little smaller. All right, which phase change is happening between E to D? And we're going to the left, we're going downhill from E to D. Oh, yeah, water should be liquid, yeah. But this is backwards, yeah, it's going from a gas at EF to a liquid at CD. And what's that called when you go from a gas into a liquid? Oh, you'd already put it up there, Nick. It's super fast. So condensation, can someone put that on the board? And you can use that A with the square around it to type. And then from A to B, what kind of energy is increasing? Fabulous. I'll just move that. So from A to B, yes, the kinetic energy is increasing. Remember, kinetic energy is just the temperature. Temperature is the average kinetic energy. Fabulous. Thank you for putting that on there. And then from B to C, the potential energy is increasing. So all looks good. Okay, so let me go back to my PowerPoint. And I want to just see, give me a 1, 2, 3, 4 in the chat and let me know how you are feeling about your interim. Whoa, Nick, a 5. Wow. Excellent, excellent. I look forward to seeing that one. A 24, awesome. So I released the presentation. So if you want to page through the presentation, you can do so on the whiteboard. Anyone else going to give me a 1, 2, 3, or 4? A 3, thank you, Ben. Excellent. Hey, I will be super happy if everyone is at a 3. If you're at a 2 and you want to stick around for a few minutes, you can. We do still have 5 minutes. And I did want to mention this link. It's on the purple arrow. This can help you practicing with the number of electrons, protons, and neutrons, and nucleons. Nucleons are just the particles in the nucleus. They're called nucleons because they're in the nucleus. But that link is not in your announcement. The link to all the other things, the quizzes, 2 of those quizzes are new. The middle one, the heating and cooling curves, that one is the same one we played in class last week. The Quizlet is new. In fact, in your announcements and in Canvas, in the modules, you can play against me I got in there and matched them up to see how fast I could match them. So if you like the matching activity and speed, you can play against me. And then the Kahoots, you have to have the Kahoot app. So you're going to need a phone or a iPad or a tablet, to do those. The Kahoot app is free if you like to play those Kahoots. Those are all ones that we have done in the past. So guys, if you have questions, stick around. If not, great job reviewing today. And I will see you guys on Friday afternoon at 12:30 for our test.